Okay, we're going to be doing the Crazy Ballz project, so come take a look here. What looks fun to me? What looks fun? This one looks really cool. Number 11. I just like it. It's kind of insane looking. Looks like pentagons, squares, and triangles. So number 11 is called the small rhombicosidodecahedron. Everybody say it with me. Rhombicosidodecahedron. Awesome. Okay. We're going to make a small rhombicosidodecahedron. And it's made of 20 triangles, 30 squares, and 12 pentagons. Now, one thing you'll notice in any of these is that the side length, whatever it is always the same. So, whatever my side length for my rectangle is, it'll be the same as my side length for my triangle and for my pentagon. So basically, all I need to do is construct one of each, color them, photocopy them, and put it together.
Oh, that's cool.
Not that hard.
Yeah.
So, one thing I was thinking, if we think about the crazy balls we have, when you have a 2-inch side length, you end up with a pretty big ball. When you have a 1-inch side length, you end up with a smaller one. Now, it's actually easier to make a big one, but it takes up more space and takes more time. But it's easier because then you don't have to use really tiny motions to put it together. So I really vote for 2-inch. 3 inch is really big. 4 centimeters is a good size, because 4 centimeters is a little less than 2 inches, but it's a good size. Just for the heck of it, I'll do 4 centimeters this time. So, to start, I'm going to do my square. So, of course, I make a segment, and then I make my 90-degree angle, and my 90's right here. It would be really awesome, anybody who wants to go ahead and do that really great square construction that we did, which I am not doing just to save time. But if you would like to do the square construction with the perpendicular bisectors, that would be really cool. You can also, of course, do the triangle construction with perpendicular bisectors.
I can do that.
Of course you can. Except for you would use the equilateral triangle construction, not perpendicular bisectors. I don't even know why I said that. Okay. So, my square is done. Now let's make sure that we're clear about this. This square has 4 centimeter sides, and of course it has 90-degree angles. My triangle has to also have 4 centimeter sides because they're going to match up. So again, I'll do 4 centimeters. Can somebody hand me a compass?
Why don't you just do it with the segment that you have on the square?
Because it'll make it tighter. I don't want it to be tight like that because I want to be able to cut them out separately.
Right.
It's a good, valid question, but that's my reasoning. Anybody give me a compass that works faster than this one? Wow. Okay, I like cheap tools, but that's going a little far. It's kind of junkyard. But okay.
Oh my god.
There we go. All right. There we go. And of course, this is our equilateral triangle construction, which is faster than measuring with a protractor and just as accurate, if not more so. So, awesome. There is our equilateral triangle. Also, another reason to do large sizes is that you're going to color them. The bigger they are, the more interesting you can color them. It's hard to color really tiny things, but larger things are easier to color. All right, the last one I'm going to do is what? Who remembers? Pentagon. It's a regular pentagon. So, in case you don't remember, this chart tells you everything. 5-sided is called a pentagon. Each interior angle will be 108 degrees. So, I'm going to make 108-degree angles. So, I use my protractor. There's 110. I'm going to go right there for 108. And from here to here, I just do segment, angle, segment, angle, segment, angle. And how long are my segments again? Who remembers? 4 centimeters, of course. Okay. All right. And I should end up with something, quite a bit like a regular pentagon. Every side should be 4 centimeters Each angle should be 108 degrees. All these will be 4. Now let's look back at it because we're doing what is it called? A small rhombicosi dodecahedron. That's right. Thanks, Alex. Thanks for the clarification. It has 62 sides, 20 triangles, 30 squares, 12 pentagons. So 20 triangles, 30 squares, 12 pentagons. So what I'm going to do, and this doesn't need to be taped, I'm going to color these in a creative way, and then when I can have that done, I can copy them until I have enough of everything. Does everybody get how that works?
Right.
So by doing that, I don't have to color every single side. I don't have to color 62 things. I just have to construct 3 things and color.
Different color?
You could do 2 different types of triangles. There's lots of creative ways you can do that. In fact, I'm going to address that. Next time you look at this, you're going to see that at the next step. Thank you. Okay, one of the good things you can do to design these things really geometrically is you can use what's called diagonals. For instance, with the pentagon, I connected from vertex to vertex. These are called diagonals, the segments that go across a polygon. When you connect the vertices, the diagonals inside of a pentagon, you end up with a star. So that's what you got here. And the square, it would just be a boring old X, and I don't want a boring old X. So what I did is instead of doing diagonals, what I did is I went from the midway point of each segment to the opposite corners. And that got me this really interesting star shape. And then it was really easy. I just colored every other triangle blue, left the rest white, and it came out to a pretty interesting pattern. The triangle is okay. I just went, again, from each vertex to the center of the opposite side. And what that did is it broke it up into these little triangles, and I colored those opposite triangles the same color just for a pattern. Now I have to photocopy. I have to make sure to get 12 of these, 30 of these, and 20 of these. I'm going to try not to waste any. So what I'm going to do first is I'll probably make 12 copies of this sheet. That'll give me 12, 12, and 12. Then I'll cut this one out. I'll make 8 more. Then I'll have 20, 20, and then I'll make 10 more of this one alone. Does everybody get what I'm talking about?
Yeah.
Then once I have it, bam, I build my ball. Cool. So here we are, again, looking at our figure, the small rhombicosi dodecahedron. If you notice, the pentagon is sort of the main shape. And the pentagon is surrounded on all sides by squares, and the squares are connected by triangles. So what I did to strategize for this is that I didn't cut out the pentagon completely. That way what I can do is I can tape my squares into place on top of it. You'll see what I mean right now. So when I put my squares upside down over the pentagon, I line up the sides. And see, this is a lot easier than trying to tape inside of something. Let's just do the whole thing inside out, and then we'll turn it back the right way when we're done. So here are 5 squares around a pentagon. And what we can do now is we can fold them all to the outside, and we connect them with triangles. So each square is going to be connected to the next square with a triangle. So take that right there, connect it to this one right here, like that, side length to side length, and then we'll take the next square over and we'll do the same thing. So here's the next square over, and then connect it to this one right here. So now these ones are connected. We'll do the same thing with each square until they all kind of come together. Here's this triangle. This triangle will touch this square right here. And then this square will come to this triangle right here. You can start to see the shape starting to happen. It's starting to curve, like a curved surface, like a ball, which is, that's what it is. It's a ball. So that's not really a surprise. But it's starting to take its shape. And it becomes really just a pattern. And that's one of those beautiful things about geometry, is that once you've got a pattern, you can kind of figure a lot of things out. And as you can see, we've got this, which is the beginning of the ball. It's basically the same thing you see right here. So what we would do now is we could add squares to each of these triangles and then continue with further faces along the way. Eventually, it's going to form a complete ball. But that's just a start. There's the idea. So next I'm going to show you the complete. All right, so our crazy ball is finished. Let's take a look at it. Okay. As you can see, yeah, that's right, Roma's holding it up. As you can see, what I did is I taped it together underneath as I was putting it together, and then I tried to tape over the edges at the end. Look. I know. It's not perfect, but if you tape it together and do a good job, you'll end up with a pretty good looking crazy ball.
Daddy, I propped it in.
This one's pretty good. Thank you, Roma. And you can do your own, and it'll be awesome. Throw it up in the air. Yay!